Okay, this will be the last video I do on trigonometric integrals, but this video has to do with products of sine and cosines where the angles are different angles. So not necessarily powers, but where you have, like maybe you have cosine 5x times cosine 3x. So there's actually an identity for when you have cosine of ax times cosine of bx. So the identity goes something like this. If you have cosine of ax times cosine of bx, you can rewrite that as 1/2 the cosine of a minus bx plus 1/2 the cosine of a plus b times x. So for this particular function, I could actually rewrite it as 1/2 of the cosine of a minus bx, so a would be 5 and b would be 3. So cosine 5x times cosine 3x can be written as 1/2 of cosine 2x, because 5 minus 3 is 2, and then plus 1/2 of cosine of a plus b, so that would be 5x plus 3x, so that's be 8x. And then the 1/2 I just factored out here, since both of these is multiplied by 1/2, I just factored the 1/2 out. Okay, so now you just have to integrate cosine of 2x and cosine of 8x. And you should know how to do that by now. If you integrate cosine 2x, you actually get sine 2x over 2, and then multiply it by 1/2, and that'll give you sine 2x over 4. So that's that term. And then if you integrate cosine of 8x, you're going to get sine of 8x over 2, and then multiply that by 1/2, and you'll get sine of 8x over 16, and then of course your constant. Okay, now what if we have a sine of an angle and cosine of an angle here? Well, there's a formula for sine of ax times cosine bx, and that would actually be 1/2 sine of a minus bx plus 1/2 sine of a plus b times x. Okay, so here my a is 3 and my b is 5. So sine of a minus bx, that would be sine of negative 2x. And then sine of a plus bx, that would actually be sine of 3 plus 5. So that'd be sine of 8x. And so on this one, I actually just went ahead and just integrated it from here. So this one, if you integrate, now remember when you integrate sine u, you actually get minus cosine u, I believe here, right? So when I integrated this first term, and what might confuse you is I switched them around, but when I integrated this first term, I actually get minus cosine of minus cosine of minus 2x all over negative 2. Well, that's going to be minus divided by minus is going to be plus. So I'll get plus cosine of minus 2x and then over 2 times 1/2, so that'll give me 1/4. And it turns out that cosine of minus 2x is the same as cosine of positive 2x. So therefore, I can replace the minus 2x with positive 2x. Alright, now this one, when I integrate this, I'm going to get minus cosine of 8x all over 8, and then multiply by 1/2. So that's going to give me minus cosine of 8x over 16. And then, of course, you throw in the constant at the end, and there's your final answer. Now, of course, if one of my integrals, I could have done a third integral, but I didn't do it. But in case you have sine of ax times sine of bx, you would actually have to use this identity in that case. So sine of ax times sine of bx is 1/2 of cosine of a minus b times x minus 1/2 times the cosine of a plus bx. So I'm sure now that you see how to handle these, if you ran across that case, you could apply that identity. So again, you have basically you could have three cases here: cosine of an angle times cosine of an angle sine of an angle times cosine of an angle, or sine of an angle times sine of an angle. So that covers all three cases.